Hello, welcome to stream number 20, where we're making an NES game from scratch here live on Twitch. I'm gonna just kind of get right into everything because we're making some good progress here with the asset tool. One quick administrative thing: I'm going to be off from the stream next week, so no stream Monday and Thursday of next week. I'll post that on Twitter anyway, just so anybody who hasn't seen the video doesn't try to join the stream and ask where it is, but just wanted to put that out there. So let's get started. So right now with the asset tool, we've got some assets loaded here. I have this creating a window, and you can see that the window is actually popping up above this stuff. This isn't quite done yet. It's sort of working the way that I wanted to, but there was a whole bunch of refactoring I had to do for the asset tool to make it work in a way that supported things rendering in a way that made sense. I mean, similar to the list type, where we do begin list, or begin list if I actually type that. List begin. We have window begin, and then within the window you have the label and the button just closes the window by making it not visible anymore. More importantly though, I want to get some map data actually rendered out to the screen and have us load that. One of the things that I thought about here is the fact that we are intermixing sprite and background data in this one pattern table on the left here, and I probably want to split it to background on the left and sprites on the right here, just to make it easier, because if I remember correctly, for the name table, and we'll go to the NES Dev reference for this because I don't remember exactly, but for the name table information, I believe you need to choose which one you want to use for each tile. Let me take it back. You got to choose which one you want to use for the tiles that you're putting into these registers, and then on the flip side for the sprite, it's because we're using the 8x8 sprites. I believe you also choose which one, and you can only use one or the other. So for 8x16 sprites, you can use that with you can swap which one you want to use by using the bit in the tile part of the OEM data. So let's go back to this for a second here. So when we are actually went too far back here, if we go to the PPU and we look at the OEM data, if you remember when we were looking at this, this bit is the bank, either this one or that one, that you want to use for your sprite in 8x16. Otherwise, it uses, you can see it says uses bit 3 from register 2000. So that's this bit here. And right now we're using the left pattern table for our backgrounds, and then for the sprites, we are using the left pattern table as well. And I want to switch it to using the right pattern table, which will obviously break things for the sprites that we're rendering in the game at the moment, the limited number of sprites we actually have. But the benefit of doing that is that then we're kind of separating out things. Obviously the palette colors are still wrong, but that's okay. So let's do that real quick. So the way we do that is when we're setting up our let's see. Yeah, so when we're doing the write to 2000 here, come on, where is that page? Where'd it go? Did I close it? No, it's right here. Let's see, so that's sprite and that's background. So we want to do 1, 2, 4, 8. 1, 2, 4, 8. So we want to set that to be 1, and then just make sure any other time we're setting it, we're setting that to 1. Load A, yep, that's fine. Just want to make sure we're properly setting that every time. And like I said, that's going to obviously break our sprites from rendering properly, but that's okay for now. What we're going to do is we're going to properly offset the char RAM to allow us to compensate for that, and then the sprites will start working again. Okay, cool. So that's what I wanted it to do, and then we're gonna go into the asset tool, and what we want to do is we want to actually offset. Right now we're not doing anything with the background data. Oh, that's not true. Actually, we are loading up our metadata, our meta tiles. So two things. One, we have to change in the assembly. We have to change which order we're loading the tiles versus the entities, right? So meta tile char would need to be loaded first. The other thing is, because we're doing this, we don't need to offset the sprite tiles anymore, so we can set that current tile to 0. That'll be good to do, and so then by doing that, when we export the project, if we copy all of that stuff back over, let's copy all of that back over. Okay. I'm just going to replace those files, and then I'm going to rebuild shooter, and we'll go to that, and so that still works. Let's go to our PP name table viewer, that's fine. PPU viewer, that's fine. So we have our meta tiles, and then we have our sprite data. Now we got to offset the sprite data by however many tiles are left in the char RAM, right? Because that's how, so this first left palette of tiles are just the first however many tiles, 255 tiles. So we need to offset the number of background tiles by however many are left over after we add the meta tiles to this. So let's see, so 59 in hex. I think that was 89 was what I saw when we were doing that. 59. So it's 89. So for the background tiles, we need to offset the count. So these are the meta tile definitions. We're including that, and then so we say int current bg tile equals 89. We do it in hex just to keep it consistent with the emulator, just to make it less confusing. And then for every meta tile we write, we're going to do current bg tile plus equals, it's 32 by 32, so that's 16 tiles, right? And then, I can't spell, And then once we're done with that, what we need to do is we need to write out however many tiles are left or are required to fill up the rest of the char RAM with nothing. Let's see. So current BG tile. Well, let's do this. For int I is equal to current BG tile. I is less than 255. I think I'll have that right. And then each tile is, what is it? It's 8. So it's 16 bytes, right? So essentially, well, actually, you know, we don't even have to do it like this. We can just write one big empty file. So let's do that. Open S. Is it open S? What? I still don't remember these Microsoft. Oh, S open S. Okay. All right. Int file equals -1 file. Call it filler dot char or asset filler dot char. O binary. Oh, it's underscore O binary. Underscore O create. Oh, what are the dumb flags for this? So we want O. Well, let's do the share flag. So share, deny no, and then what was the other one? Permissions, si write, and then I didn't need the underscore to precede that. O binary, O create, O write only, O truncate, because we want to truncate it if it exists already. And then we say if file is greater than or equal to 0. Then we want to write the number of bytes. We want to write a number of bytes equal to the filler that's necessary, right? So I guess we can actually do that. So int filler equals 0. So that's going to be 4 bytes to write, and then we can do write file filler size of int. We just do that. Well, should we just allocate a buffer that's the appropriate size and make that 0 and then write that? That might be better in this case, just to make this as simple as possible. So character filler buffer equals malloc size of char times 255 minus current BG tile. And then I guess, you know, if current BG tile is less than 255, right? Because we don't need to do this if it's 255. I mean, it shouldn't be higher, but we'll probably have to check that. Although thinking about this will only work for this will only work if the meta tiles that we have don't exceed that, regardless of how many maps we have. So we're gonna have to circle back to this again, but that's okay. You know, again, I'm kind of more interested in getting some of this stuff to just load, since we've been tinkering around with the asset tool so much. So let's memset the filler buffer with 0 size of char times 255 minus current BG tile. And that needs to be in parentheses. And that should actually be times, no, that's fine. Oh, no, it's not times, because it should be 16 bytes, right? Times 16 bytes, because each tile is 64 by 64 bits. Sorry, 64 by 64. Damn it, sorry. Each tile is 8 by 8, which it's 8 bits by 8. I know it's 16 by 16, but I'm having a hard time explaining. So if you remember how we talked about it, right? There's the two parts of it. There's the each pixel is actually 2 bits, right? And so then each row, let's just say that's 8 bits. That's another 8 bits, so that's 2 bytes, and then there are 2 bytes per 8 rows, so there's 16 bytes, right? So we have that mem set, and then we're going to write to file, filler buffer, size of char. I'm going to pre-compute this now. Buffer size equals size of char times 255 minus current BG tile times 16. Buffer size. You know, eventually you're just like, how many more times am I going to have to recompute this? And yeah, the compiler might be good at deciding it needs to cache that for you so that you don't have to actually recompute it, but there's no reason you can't just do it yourself. Right, so it should be underscore write. So that's going to write the file, and then underscore close, yeah, close file. So that should write our filler. So let's see. So if we right now have 89 tiles, and then we're going to add 2 meta tile sets, right? So the meta tiles are 16 tiles because it's 32 by 32, which is 4 tiles by 4 tiles. So that's 16. So plus 16 plus 16. So that's going to give us 121. So 255 minus 1. 255 minus 121, we should get 134. So 134 remaining tiles need to be written to this filler buffer times 16 bytes times size of char, which is 1. So that seems too big. That's 2K. It seems too big. Maybe it's not. If I go to, where is the assembler? It is under NESDev, CC65. In the config here, it has some predefined configurations, and this is the one for the NES that defines the 0 page location and size, and the chars. ROM2 is size is 2000 hex, which I don't know. My hex calculations suck. That's 8K. Okay, no, that isn't too big. That's fine. All right. So, all right. The only other thing we need to do is we need to tell it to actually include that in our meta tiles. File char new line semicolon. All right, so now that should write that it should use the asset filler file. So if I hit export, Assuming that that all worked, we should see asset filler there. It's saying it's 3K. What is the actual size? The actual size is 2144, which is what I calculated. That's good. Alright, so then I'm going to take all of this stuff and move it back over to the shooter project folder. We're going to replace all that content. Go back to Sublime Text. Where are you? Look at the shooter char. We've got entity char and meta tile char. This includes. We've got our asset filler. It's not doing the full path, which I guess is okay. I guess it should technically, but let's see if this causes that to reload properly in the pattern tables now. Oh, almost. So it's, what is it, off by 1? Well, that's not bad for... I usually screw those things up pretty badly, so I'm pretty happy that it actually... Oh, you know what? We're off by 1 because we have the one empty tile in the beginning. So make that 60, or let me think about that for a second. So we're 1 short. Yeah, I was right. So it's 60. So let's close the asset tool, rerun that, and export the project again. NES asset tool. All right, all that stuff gets pasted there, and then rebuild it, and then relaunch it, and name table, PPU. What? Oh. Right. It was 59, which doesn't mean 60. Actually, I was right in questioning that because it should be 1 less. Okay. Also, 59 in hex plus 1 is not 60. It's 5A. Yet another brilliant error. You know, these are the mistakes that you normally make in the privacy of your own space at your desk without anyone else watching normally. Not sure anybody needs to be seeing me make these mistakes, but that they happen. You just, you know, as you're focusing on one thing, you're not paying full attention to what you're doing, and you make a dumb mistake. All right, cool. So now our sprites are loading from the appropriate pattern tables. So the sprites are here on the right, and the backgrounds are here on the left, which is what we wanted. That's good. So now, let's start loading. I want to load the gradient tile in because it's going to be the most interesting, I think, of all of the assets we have right now to load into the background. And what I want to do is I want to load that into the background after we hit start. So obviously we don't have any sort of concept of a level yet. Let's start with that. Close the asset tool. I'm going to call it sort of more generically a map. And I want to what I want to do is I want to make it right now just fill the 2 screens that we actually have available. I don't want to worry about the scrolling yet. but I want the structure to support more than just the, what is it, 32 by 20 that the NES supports. Right, 256 divided by 8 is 32. And then 240 divided by 8 is 30. Oh, yeah, 32 by 30. And if you do 32 by 30, you get 960, which means, if you remember, we talked about this, these 64 bytes here, these are the attribute values, which we will use to manipulate things like the palette for the background. For now, we're not going to touch the background just because, yeah, we're just still kind of working on getting all of this other stuff going. So let's do this. Let's establish that there's a width and a height. We'll do the same thing with a version, even though we're not using it right now. We have our width and our height. And then once we have that, we don't have layers or anything like that. We just are going to have references to the meta tiles. So that's the other thing. Like if you remember, we were talking about this. The meta tiles are 4 tile by 4 tile representations of graphics. So if this is our screen, we're going to be drawing in essentially chunks that are bigger than the little 8 by 8 that you would normally support. And the nice thing about that is that then instead of having 32 values across for the horizontal tiles, you have 8, right? Because 32 divided by 4 is 8. And then for the vertical, it's 30 divided by 4. So it's not quite an even number. What is it? 7.5? Is that right? 7 times 4 is 28 plus 2. So it's not quite an even division. 16 doesn't work either. It's kind of annoying. Well, it is what it is. So again, you're going to have 8 by 7 meta tiles. So how does that work? How would you deal with that nonsense? Well, if you have 28 tiles and then you have 2 rows left at the bottom. Well, you know what? Let's just get this working, and then we'll figure out how we're going to represent. I mean, basically, what you would do is you'd actually just do 8 by 8, I think, and then you cut off the bottom 2 tiles, right? Just to make it simple. So the width and the height are going to be a representation in. I guess they're going to be a representation in the width and height of the number of meta tiles. And then let's see. And then we just have our pointer to meta tiles, right? So I mean, we may have to change that, and that's fine. I'm still obviously kind of figuring this part out. So save map, map pointer, map character, file name. Okay. I don't know that we need to worry about doing this yet. Because right now I want to just essentially use the meta tiles that we have right now. realistically just want to write out some map data by hand just to get it first to load it the way we want to, and then after that we'll figure out how the asset tool will handle it. So let's do that. Let's try that. So let's call that like level 1. Right now we have 2 meta tiles. We have the meta tile with the solid color and the meta tile with the gradient color. So let's call those you want to just call those 0 and 1. Trying to think of what's the do we need an empty meta tile? Yeah, we do need an empty meta tile that doesn't do anything, so we'll call them 1 and 2. So let's start off by doing an 8x8, so 2 of those. So right, that's C notation. So 8 of those, 4, 5, 6, 7, 8. So that's 1 screen. And then the second screen. Again, this is totally just me kind of kludging this together to get something to display properly. So then we also need to create a mapping into the meta tiles. So for example, we know the meta tiles are going to be 16 regular tiles. And where do they start? So they start at 59 hex. So 59 5A, 5B, 5C, 5D. How many do we have there? 4, 5, 4. Let's get the right number of them and we can count them up. So that's 8, 12, 16, 5, 9, 5A, 5B, 5C, 5D, 5E, 5F, 60. Oops, not 71. Having issues typing today. 65, 66, 67, 68. And this is just to kind of prove that what I'm thinking is going to work. So that's the first meta tile, and then the second meta tile should be at 69. Right, if I mouse over here, yep, it's at 69, so I can just copy this and update the 5s and 6s. And then basically what we're going to do is when we get, as we load the data out of the level and we see a meta tile, we know that we want to load, well, that raises an interesting question. So like what, when we're loading, if we're loading horizontally, so the NES has 2 ways of loading the background name table. It has one way of loading it, which is that as you send it tile values, it's incrementing from one tile to the next, right? So you give it a value, it increments. You give it a value, it increments. You give it a value, it increments, right? And it just does that across one tile at a time. There's another way that it does that, which is for scrolling horizontally, where it increments to the next line, and you give it the next value, and then it scrolls to the next line, and it just keeps doing that over and over and over again. So the thing with that is that you want to be able to efficiently, Well, I guess it wouldn't be that hard, right? Let's see. So if you're indexing through this, you do the four tiles for that for 4 rows, right? And for each time you do that, you would be jumping into this. I mean, I could see potentially that being maybe not so efficient to do that way, but well, let's get this going, and then we can talk about when we need to load map data in real time, if we're going to run into problems where it's going to be inefficient. And I'm also curious about if you've got a meta tile, if you're scrolling up, the meta tile above where you're scrolling has to be loaded. But I guess you have to look at, okay, yeah, so you'd have to look at, okay, what is the row of meta tiles, and then index into the last part of the meta tile. I remember someone on the Nintendo Age Discord talking about this. I'm going to have to go back and look at what they were saying they were doing to index into this efficiently. But we'll go this route for now, and then we can always fix this. All right, so right now, we want to load the background when we transition from title screen to load new game. Right, so right now, yeah, so we need to load the tile map. So when we want to write the name table, let's take a look at this. So what is this doing? That's the scroll register. This register is used to change the scroll position. Well, actually, we've got this here when we load the title screen, right? So let's see, where is that? Where is that code for loading the tiles? Load background. Jump load background. So this is the code that was doing the sort of pseudo run length encoding that can be switched on and off. So, okay, so it's 2007 is the register to write the data. Yeah, and then let me think about this. So how do you have to reset the location that you're writing to. Where is that? You do that in, is that in 7FE? Or is that no, that's my debugging stuff. So actually don't need to do that anymore. Oh, 2006, that's what it is. So, okay, so in 2006, you're going to write to what part of the memory you want to write to with the 2007, where is it? With the 2007 register, right? So, for the background, or was that only for the palette? No, that's for, this is loading the palette. Yeah, okay, no, it's for both. Okay, sorry. So we want to write that we want to tell the PPU that we want to write to the name table. And the name table memory address starts at 2000. And then we just keep writing to the 2007 register with the information about the background. So let's do this. Let us, again, just to get this going, just to make sure that that I actually understand this the way that I think I understand this, we're going to load new game state. Okay, so all of this stuff, store 2000, blah, blah, blah. Okay, so we're going to tell the PPU that we're going to be writing to the address 2000, which is the name table. And then what we want to do is we want to start writing tiles. So just for kicks, let's do this. Let's load X with 0, and then store load A with what is the tile? With this tile. Let's do the next one, 6A, and then load tiles, store A in 2007, increment X, compare to 2. How many tiles is it? It's 32 by 30, right? So 960. Let's just do 255 for now, just because I'm going to be lazy about this. Branch if not equal to load tiles. So we're only going to load 250 tiles, even though you can load more than that. But I just want to first make sure that it's actually going to load the tiles, that I actually got that right, and then, whoa, no, I didn't. Load A with the address, increment, oh, yeah, that's never going to change, right? It should be CPX. Okay, cool. So it did load those tiles, and if you look at the name table, right, it loaded some tiles in there. It obviously didn't load the meta tiles like we wanted, but that's okay. So let's do that part now. So we need to, the way that this is going to work, that's kind of interesting, is we have our meta tiles, right, which are we have 8 by 8, but each of these meta tiles is actually 4 by 4 regular tiles. So first we have to index into the meta tile map to find out what meta tile we're drawing, and then we have to get the appropriate row of meta tiles that we want to draw, right? So let me think about how we can do that. I mean, in theory, should be able to do, this is where my being a total noob at 6502 assembly is still giving me some growing pains. Should be able to, instead of just using A blindly, should be able to do load A meta tiles X like that, and we'll get different values now. What, 369. What's the problem? Y expected. It really wants Y, huh? Range error 369. Oh, really? Load A. Right, because it can only do 0. Oh, dummy. It doesn't need to be in parentheses, and then I should be able to use X, I think. Alright, so now we should start seeing a little bit more interesting info or graphics being loaded. When we hit start, it still won't be right. Okay, cool. So that's, now we're seeing sort of random. They're sort of random. It's our meta tiles, but then there's some additional stuff that's coming from the fact that there's other data that we're reading into that is beyond what's actually in. Not there, beyond what's actually in this. So the bullet collision data, the palette data, all of that stuff. So that's why we're actually seeing some additional data here in the name table that is referencing the text for the streamer title screen. Alright, so that's better. So what I want to do, so Y is going to be the index into our meta tiles, but we also need some way of ensuring that we're indexing into the meta tile map properly. Let's see, so and that's going to be relevant for the way we're indexing into the actual meta tile data itself. So it's almost like what we need to do is we need to be keeping track of the X and Y across this, not for the meta tile map, but for when we want to look into the meta tiles. And that part shouldn't be hard. I'm just worried that that's not going to be super efficient, but well, let's give it a shot. All right, so tile X, tile Y, tile load new game state. Right, so let's load new game state here. We want to store. I always forget if you can do that. One of these days, my brain will actually remember these 6502 instructions. Tile X, store X, tile Y, because we just need that to be 0. We need Y to be 0, X is 0, good. And then what we want to do is we want to load a meta tiles X. So, right, we'll get to that. We'll get to all of this in a second. So we're going to load that. We want to increment tile X. Well, so actually we want to load X with tile X, and then what I want to do is I want to shift it to divide by 4 right? Because the tile X is going to be counting by the number of actual tiles. The meta tile map is actually only referencing the meta tiles. So was a shift right? Is that only was LSR, logical shift right? Is that only available for A and oh, and you can do it for an address, but that doesn't help me. You're no help at all. Load A with tile X and shift right A 4 times. Wait. You can only do that 2, 3, 4. And that's not the right instruction. So that divides it. Oh, wait. I don't want to divide by that many times. 2, 4. I only want to do it twice. So that gives me that, and then transfer A to X because we want it to be an X, and then it's going to load A with the meta tile value that we want, and then that's for the X value. And then we got to do, oh, we have to do the same thing for Y. Blah. Let me think about that for a second. So Y, if it's 8 by 8, 64. Okay, that won't be a problem. Okay, we have to do the same thing though. Load A with tile Y, divide it by 4, and then that tile Y needs to be multiplied by 8. So wait, so we're dividing by 4 and then multiplying by 8. Right, because we want to know what the range is in here, and then we need to index in with the X. So we have N divided by 4 times 8. Is that just 2N? It's been a while since high school algebra. Because 8 divided by 4 is 2. So if I'm at 0, no. If Y is at 0, then it should be, well, it would still be 0. If Y is at 1, then we're going to get 2, but it shouldn't be 2. It should be, what should it be? It should be 8. Why is my math so janky? Come watch Mike struggle with math. What the hell, man? So oh wait, it's not divide by 4. No, it is divide by 4 because that's okay. So if it's the first row, it should be 0. If it's the second row, it should be 0. If it's the third row, it should be 0. If it's the fourth row, it should be 0. And it's 0 index, so that would be like 3 divided by 4 would give you 0 times 8, right? Which is 0. And then once you hit row number 4, you're going to get 4 divided by 4, 5 divided by 4, 6 divided by 4, 7 divided by 4, right? And then you do times 8, and all of that's good. Do I have to make this like an equivalent fraction? Is that what I didn't do right? So is it like 32/4 in order to multiply that? 32n over 4, and that gives me 8n. Wow, that's embarrassing that I don't know. I think the problem is that I should just be able to do the divide by 4 and then let's just do it the lazy way because I've already embarrassed myself enough with this really crappy math that I was trying to do. Maybe it'll come to me while I do it this way. So let's logical shift right. Then arithmetic shift left. Bits left one position, 0 is shifted into the bit 0, and the original bit 7 is shifted into carry. And then logical shift right. 0 is shifted into bit 7, and the original, yeah, so, okay. So then, arithmetic shift left, I gotta do 2, 4, 8. Something's still bothering me about this. Why is my brain not working? So if this is gonna be 0 through, so this is gonna be 0 through 3, right? And for 0 through 3, we want the value of 0. And then 4 through 7, we want the value of 1, which is just divide by 4. Right? But that's fine, but then I want to get the index into that because, and you've got to multiply by the 8 for every row, right? So this should turn into, should actually be 8. So the two times that works for this, but obviously it doesn't work for 5 or 6 or 7. And the only reason that it works the other way is because when you do these shifts, you're losing the bits, and it's effectively just doing shorthand division where you're not interested in the fractional part, right? You just want the integer part, which is why you can then just multiply by 8 afterwards, like I'm doing. I don't know that you can actually do the combination like I was doing before. Maybe that's why my math was sucking, because you can't do it because it relies on the fact that you're losing the bits. I mean, I know in like C, what I would essentially do is if they were integers, I'd probably just do, you know, y divided by 4 times 8, knowing that the divide by 4 here truncates it, and then the times 8 is just multiplying by the whole number part and not the floating point part. So I guess that's fine. I was just trying to see if there was a way to do it more efficiently with fewer shifts. Alright, so that gives us now our index on the y side, and then what we want to do is we want to add that to A. Oh, sorry, we want to add that to X. There is an add with carry. We can increase X. So what we want to do, I guess, let's see, we want to, I guess, put this into memory, into something. Instead of just moving this to X, we want to say store A into temp. And then once we have that value, then we want to clear carry and add carry to temp, and then transfer A to X, which gives us our index into meta tiles that we want. And then from there, so at the end, yeah, so let's do this. Compare load a tile X and then compare that to 8, and then if branch if not equal to skip next row. So this is basically, if we hit 8 on tile X, then we want to load A with 0, store A tile X, increment tile Y, load A tile Y, compare it to 8. And this is only going to load one screen, but that's okay. Branch not equal load tiles, otherwise jump to done loading tiles, not files, tiles. Done loading tiles. We don't need to be doing this here. We want to do this somewhere up here before we start messing with incrementing tile X. We don't need to do the increment there. We don't need to do that. We just do our jump. All right, so that's going to store A. That's not exactly what we want to do. What we want to do is, now that we know which meta tile we're dealing with, now we have to find the actual tile value for the meta tile that we're currently drawing. So that's basically going to tell us, okay, how many bytes do we need to skip to get to our meta tile indexes, and then once we're there, we use the X and Y to determine where, or do we need to use the X? We don't need to use the X, but we do need to use the Y, because depending on where Y is, it will determine how far we have to index into the meta tile itself. So that tells us which meta tile we want. And then I want to multiply that by 16, because I want to find out how far into the meta tile data that we want to get, right? Except I think that's, yeah, so that shouldn't be meta tiles, this should be level 1. So arithmetic shift left, 2, that's times 2 times 4 times 8 times 16, is that right? Binary 1, and then we're going to shift 2, 4, 8. Why aren't you shifting? Oh, 2, 4, 8, 16. Yeah. 1, 2, 3, 4. Yes. Okay. Trying to minimize the mistakes. All right. So now that we've done that, then we can load. Now we know, okay, that's where the beginning of the meta tile is in the meta tile data. Let's store that in temp. And now we need to calculate, we need to take the tile Y and figure out, we need to figure out where in the meta tile Y we are. So if we are at 0, 1, 2, or 3, this would be, it's pretty straightforward because we're just using that as is. And then if it's at, let's say, 5, realistically, so if that's 5, at that point we want it to be essentially 0. So we want sort of a modulo almost, where it just keeps rolling over. How would you do that? I know there's no modulo. Is that just, are you just doing a divide by the number until you have a value less than a number? I mean, you could do that. That seems pretty inefficient. I don't like that idea. What we could do to make that a little bit better is we could use a separate counter into the meta tile. Oops. And let's see. And so when we increment this, increment m tile y, and load it and compare it to 4, and check. We'll call that check tiley, and then we'll just load a 0, store a into m tiley, and then check tiley, load y. Branch not equal to the, oh, you know what we didn't do? Load a 0 and store it into, oh no. No, that's it. Oh, that's not right, though. It's not 8, it's 30. Not 30 in hex, though. 1e, right, because that should be, and then we made the same mistake with this. This shouldn't be that, it should be, let's see, so if 1e is 30, f, what is that, 20? 32? Yeah. So, because we're incrementing this for every single tile we draw, even though the meta tiles in the map data are not representing every single tile, right? So let's see. So that's okay. This does need to be checked at 4 because this is what we're using to get into the meta tile. So let's see. So store it into temp and then use load m tiley, and then we want to multiply that by 4. So ASLA, ASLA, and then clear carry and add carry temp, and then that gives us the actual tile that we want in meta tiles. Transfer A to X, X, store that. This seems like that should work. It doesn't seem very efficient, though. It makes me nervous. Okay, well, it definitely loaded the name table with data. but obviously not what we were expecting. So let's do this. Let's what? Oh. Let's get my breakpoints going back here again and see where I messed this up. I'm sure there are multiple places. Oh, and it's 7FE, not 7FFE. Those are very different places. Delete that one. All right, so let's start by looking at this. So we're loading compare 0. What is this? No, that's not. Oh, that's the other debug point for the sprite. Right? Oh, is that gone? Why is it? What is it breaking on? Store A7F. Store. Oh, no, that is the right point. Okay, sorry. So we're loading A with 20, storing it in 2006, telling it we're going to load basically the name table now. So we're setting X to 0. We're storing X in tile Y, in tile X and M tile Y, and then we're loading Y with 0, although we probably don't need to do that, but that's okay. So now we're loading A with the value of tile X, which is 0. We're doing some shifts, which have no effect because we're at 0, 0 right now. We're storing that into temp. We're then loading the Y, and then we're calculating our offset for the Y, which again is 0. We're doing our clear carry. We're adding the two values together to get 0. We're doing a transfer to X because we're going to use that now to get the value 2. Okay, well that's good. That's so far is right. We're loading the value 2 from level 1. All right, so now that we have that, we want to calculate how far we need to index into. Oh, so there's the first problem. Even though technically it is the second one, we don't have an empty meta tile here to give it the right offset. So that is part of the problem. It might be the only problem, I don't know. All right, let's run. Turn off the breakpoint. So let's reload the ROM. Okay, that's better. Looks like it keeps reloading the same tiles. Okay, well that's cool. So that's actually better. Let's reset the NES and run it again. I want to actually see. Oh, that's pretty funny because the name table didn't get fully cleared out. You can see the residual data from the first run. Interesting. All right, anyway. So, all right, so we were good up until the point when we stepped through that it was getting the right value for the tile that we wanted, which was 2, and then 2 was being multiplied to get the offset. So the offset is 32. So if we go look, this is 16, this is 32, right? So that should mean that the first byte we get from it is this 69 in hex. Let's go back to this code here. Alright, so we got that, right? And then we got the 32. We're storing that into temp so that we can reference it later. Now we're loading mtile_y, which is 0, so we're doing some... Oh, are we not... Oh, we're not adding... Wait a minute. No, maybe not. Okay, let me just keep going with this. So we're shifting that. We're adding... Add with carry the temp value, which was 32, which means we're not doing any additional indexing into it, which is good. Yeah, okay, so that's good. So that means that now A should be 32. We're going to transfer that into X, and then we're going to load A with the first byte of the meta tile, which is good. And that's 69, that's right. And then we're going to store that in memory, and then we're going to increment tile X. We're going to check it to see if it's 32, and if it's not, we're not going to worry about incrementing anything else. We don't have to increment mtile_y until we increment tile Y. Let's see. Okay, good. So let's keep going. So where are we in this code? We are back at the beginning of the loop. We're loading A with what? Tile X, which has the value of 1. Okay. And then we're shifting it, which makes it 0 again, because we want to index into the level correctly. So now we're storing that into temp, and then we're looking at the Y value, and we're shifting that to get the offset, clearing the carry, and then adding, and we should now get the same meta tile value, and we did, so that's good. Now we want to store that into temp. That's good, we did. Now we want to get the... Now that we have the meta tile index, we want to calculate how far we have to index into that based on... oh, you know what it is? It's because we're only doing it for the Y value and not the X value. That's what the problem is. So let's see. So that gives us that. We didn't do our load A of tile X. Well, actually, so there are a couple of things there that we need to do. We need to then store that back into temp. And then we want to load A with tile Y. And then add with carry temp. Because we need to index in however much X is also. Okay. That would explain why it's only partially actually loading the tiles. Go back to the debugger and turn off this breakpoint. Run. Whoa, okay. So it's different. Let's see here. Let's make this a little bit bigger so I can actually see. pause this for a second. So the first row, let's reload this because this is strange. So, all right, so the first one worked fine, right? And then I want to see what happened here with the, is this, okay, where I want to be now. All right, so let's, can we see this in real time as we're updating it? I don't know, we'll see. So we're doing the store. We get to the point where we store the to 2007, which is here. So run to that, step over. Okay, so we're incrementing it, and then we're going to go back. All right, so same thing here. The only difference is now that the byte we get out of the meta tile information should be, did I pass it? I did. It shouldn't be 69 again. It should be 6A. So what happened? Why did that not happen? All right, so let's take a look at this. We know the first byte is fine from stepping through it. So 69, good. Compare, branch if not equal. Jump. All right, so now tile X is 1. Tile Y is 0. M tile Y is 0. So we are good insofar as we are still getting meta tile 2. And we're getting 32 as the index. We're going to store that into temp. We're going to load let's see. We're going to store that in temp. We're going to load the M tile Y, which is still 0, which is fine. We're going to shift that and clear the carry and add temp to that, which gives us that, and that's fine. We're going to store that again because we then need to load dummy. It should be tile X. And that should be what? That should actually, so that's interesting. So tile X, we're going to still have a problem, and I'll talk about that in a second. The problem we're going to have is related to the fact that yeah, so it partially loaded it correctly and then it didn't. And the reason that it partially loaded it correctly is the following. So for the first meta tile, it's going to work perfectly. The problem is that the additional drawings of the meta tile will fail because X is now going to be out of the bounds of the meta tile. And this is because X is going to be too big, because it'll be 16 or larger. Sorry, 16? Yeah, 16 or larger. So as we do this, I'm wondering if this is going to actually get simpler in a second. As we do this, we're saying, okay, X is increasing this way, and then once we get to the end, we're going to bump to the next line, right? And each time we do that, we look at, okay, what meta tile is this, and then find the tile that we're actually on in the meta tile. Once we get past this point, X is going to be 4, 5, 6, 7, and then until we get to 32, which is the edge of the screen. But what we really want it to do is we really want it to be 0 again. Just like we wanted we're using M tile Y, right? Where M tile Y is going from 0 to 3, and then it's going back from 0 to 3, and it's just repeating that because for the meta tiles, that's all we need. So I actually wonder if we don't need to be doing our count to 32 like we're doing, but have a count for let me think about that. So we need to have a count from 0 to 4 for X and 0 to 4 for Y, and we then need to also keep track of how many meta tiles we've... I actually think we can simplify this in a certain sense, because what we can do, instead of what we're doing right now, which is kind of like a weird way of indexing into these individual tiles, we just go from 0 to 8 on the Y, and 0, well, this is X, and 0 through 8 on the Y, right? And then we just have these counters that we use for everyone that we do that for, as we increment. And then we're just going to use the outer counters to index into... Well, we don't even need to do that. We don't need to index into the screen at all like we would with a normal screen drawing process, because we're essentially keeping track of where we are on the screen, or the NES is doing it as we render the as we write each byte out. Could we just use a counter? Just a single counter? So let's see, how would that work? So if we just had a single counter, we could figure out I'm trying to think if that'll work. I don't think we can have a single counter, but if we have the X and Y counter, yeah. So actually, we just need the X counter, and we just keep doing that, and then gotta think about what's the best way to do this, because this is weird because of the fact that we're using these meta tiles. We're essentially doing sort of like this double scanning across tile sets. Let me think about that. So if we tried to do this with a single counter, what would be the complexity there? So we have right, there's 4, or is there? If that's 4 times 4, that's only 16. So there's actually 8. Whatever. Imagine there are more over here. What we would want to do is the single counter would be fine to start off with if we kept dividing it by 4 to determine what meta tile we're in, because that would give us first, you know, the 0 meta tile, then the 1 meta tile, then the 2 meta tile, then the 3 meta tile, then the 4 meta tile, until we got to meta tile 7, at which point we would want to reset that counter because, or do we want to do that? Because then this is 8 meta tile, 9 meta tile. That would work. So a single counter into that would be sufficient to give us which meta tile we're working with, right? The problem is within each of these meta tiles, we have to cover each one 4 times to, right? Because we've got to get this row, this row, this row, this row, this row, all the way to the last one, and then when we come back, oh yeah, so the single counter, oh, you know, maybe, I wonder if we could do that. So I wonder if the single counter would count. Trying to think about this. So if we divide the counter by 4, it will give us this first row properly. And then when we get to 8, we really want the second row of the same meta tile that we've already scanned across the one time. So it's more like we want to, instead of counting to counting 8 meta tiles, it's almost like we want to count 32, and with each time, let's see, so if we do that, it's tricky. I'm having a hard time sort of visualizing how this would work, because I know how to do indexing into the meta tiles, and I know how to do indexing into the tiles of the meta tiles, but I don't know that I can think of a way to efficiently do both at the same time without lots of weird kludges to get at it. I feel like there should be an efficient solution to solving this, right? Because we're just like, if we said, okay, this is 32, and we divide by the number of, it's not 32, it would actually be, what is it? It would be 16 times 8, so 128, right? Because let's see, so if we're at 7 here, and we divide by 4, that's going to give us that meta tile. I don't know. Even if that gives us that meta tile, though, it doesn't tell us what position in the meta tile we're in. Well, it does, sort of. Because if we're, let's say we're at 8, and we divide by 4, well, no, so the first index is going to, oh, right, because I'm dividing by 4, not by 8, like I said originally, or I was thinking. So let's see. So the first row. Let me use a clean drawing here, because I've sort of confused myself a little bit. I'm not sure how much this is actually helping anybody. So all right, we've got the meta tile, right? And what we want to do is we want to draw this one first and then move on to the next one, which is the same size. So if this is 0, this is 1, this is 2, this is 3, that's fine if we're just counting up, right? And divided by 4, we can find our location here in the meta tile. But then we also need to know where we're indexing into the meta tile itself. And I was going to say that there's no way to know that quickly, but if you take 2 and divide by 4, you get 0. But if you have that 2 preserved, then you know that you have to index 2 into that 0th meta tile, right? Because that's still valid. The question becomes, let's just say that right now it's just going to be let's just say that right now we're going to have a 2 by 2 meta tile map, right? So when we hit 7, we're going to go to 8, and then 8 divided by 4 is going to give us 2, but that's not right, because what we really want is we want 0 again. And this is because the right, so what I'm saying is, you know, we get to 4, this whole line gives us 0 for the meta tile, this whole line gives us 1 for the meta tile, that's all good. We now increment the index, we get 8, and it's going to say, okay, you want meta tile 2. Well, we don't. We actually want to go back to meta tile 0, because we need to draw the next row of meta tile 0. In this particular example, if we condense the screen down just to simplify it, right? So let's think about this. So if we say we have two counters, we have just the x and the y. If x gets to 8, we bring it back to 0, y gets increased by 1. And then we say, okay, so it's x plus y times 8, right? And again, I know that 8 isn't actually what we're using, but just for the sake of simplifying. So if y is equal to 1, we get 8 plus, and then x is 0. That gives us 8 as our value that we're indexing into here. But that's actually not meaningful. With the two separate values, or is it? We have our no, okay, so what we'd want to do, yeah, this gets back to what we're doing right now, which is to determine the meta tile, we have to divide y, we divide y by 4, we divide x by 4, right? And that gives us what meta tile we want. So if y is 1 and x is 0, that's going to give us 0, which is this meta tile, which is fine. And then when we get into here, we have to do what we're doing, which is we have to say, okay, it's y times 4 plus x. But the problem is that x is incrementing across the whole screen and not across just the meta tile. So every time we get to this boundary here, we're going to run into this problem. And that's where a modulo would be useful, because you could say, like in C++, you'd say x mod, whoa, I guess I rotated a little bit, x mod equals 4, right? Or you actually probably don't even, that's not the right symbol, mod equals 4, but you wouldn't even want to do that. You just say, okay, I want to index into it using mod 4 so that it's always going 0 to 3, 0 to 3, 0 to 3 to get the x value we want. Boo. So, and we had introduced that other counter, the mtile y, to do that for within the meta tile. I guess we're going to have to do that for x. That's just kind of lousy. We could probably condense that down to, 2 packed bytes, where, they're 4 bits apiece, because the values aren't going to get big enough that they really need a whole byte themselves. But I really just don't like that approach. But I can't think of anything smarter to do. I'm sure there's got to be something. I'll have to look and see. So when we increment the x, then we're going to increment mtile x, and first thing we need to do is check if mtile x is compare to 4, and then wrench not equal, what did I call it? Check tile x. We'll just keep that consistent. Here we'll load a with 0 and store a into mtile x, and then check tile x. And then so basically what we want to do is, instead of using tile y, we want to use mtile y, because we just want to keep incrementing 0 through 4 here. Yes, I need a colon. And this will probably work, but again, I don't really like this approach. just feels wrong. I know that's not a great basis for the way you engineer something, but okay. And then that worked, and as you can see, there's this last row here that has half a meta tile, and that's because, like we said, the meta tiles are the screen is actually 32 by 30, not 32 by 32. So the meta tiles don't fit exactly, right? It's 32 by 30. So there's this little part here that's essentially half a meta tile that gets cut off there, which is fine. So that's loading now correctly. But yeah, man, that's ugly. So the question now is for, I guess we don't need tile Y and tile X anymore, do we? No, I don't think we do, because the thing with tile Y and tile X was that they were based on the idea that, you know, if we have our 8 meta tiles here, right? Or do we? Maybe we do. We can index through them, you know, however we want to, by just incrementing this X value, and then we'll convert it into something that fits into the meta tile. Now it's just basically serving, you know, to pinpoint which meta tile we're looking at. So the question then becomes, can we do that? Can we do that without requiring 2 counters? Or 2 sets of counters? So for every tile, maybe not, maybe we do need it, because we're iterating over every tile that we want to draw over X and Y with tile X and tile Y to determine which meta tile we're drawing. And then I guess the only thing we could do to be a little bit smarter about this is, instead of incrementing X by 1 every time, we could say, okay, whenever we, I don't even know that this is going to help anything, but we increment M tile X, and then we do the A, we load it into A, compare it, and then if it's equal, then we can just increment. So load A, M tile X, clear carry, add carry 4, and then store A tile X. That doesn't even seem that efficient. In fact, I think it's probably just better to just do the increment. This just feels kind of gross. I mean, like I said, if I were doing this in a higher level language, I'd be using the modulo so that I could use probably just 1 counter. But is that, I mean, that feels like it's going to be more complex to compute that way. I'll have to look into if there's a simple way to calculate the modulo on 6502. There might be some sort of trick to do it efficiently. Okay, so that at least loaded the map, and that did it for a 32 by 20, although interestingly it actually looks like it did it for the whole thing, which would be 32 by 40. Right, because if it were just half the screen, or just one screen that we loaded, it would only be one of the name table halves here. Oh wait, is it because of the way we're mirroring? It's possible that that's what it is. Right, because let me reset the emulator. That might be all that is. Where? Right, because I think the streamer text is doubled, and we're not loading that twice. Okay, so it's because of the way the mirroring is set up. It looks like it. I forgot we're mirroring in that way. Okay. So it is only loading the one screen because the other one is blank. So let's do that. Let's it should be loading both screens. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So that's 2 screens worth. I actually want to 1 2 3 4 5 6 7 8. I want to change this. I want to make it do half of one and half of the other, so we can actually see what we're doing here. Oops. 3 4 5 6 7 8. All right, so now the thing to know is that in all right, where is that? Init game, init new game state, load new game state. Okay, so we actually don't want to stop. So 1E is that 20? Is that what I said? Or 30. Sorry, I keep saying 20, but I meant 30. So that's the maximum. That's good. Now what we need to do is when we get to... We're not done loading the tiles. What we need to do is we need to... We're at the point where now we've got to load the attributes and then continue on the next part of the screen. So let's see, how would we handle that? Maybe we don't for tonight, because that's now what we have to do is we essentially have to skip. Well, we could just sort of brute force skip. Branch not equal. Let's call this. Okay, so this is not done loading tiles. This is, if we compare it to let's compare it first to 20 times, so it's 40, no, 60. What is that in? Oh, I'm in text mode. So 3C is 2 screens worth. So compare it, and if it's not 3C, then let's see, what I want to do is I want to branch if not equal to check I don't know what the right terminology for that is. Check screen attributes. And if it is 3C, we're going to jump, but check screen adder. At this point, what we want to do is we want to check, compare it to 1E, which should be 30. Yep. So compare it to 1E, and then if it's not that either, we're going to jump to load tiles, and then here we need to burn through the attributes, which we're not currently setting anywhere or storing anywhere. So what I basically want to do is load X with 0, and then load A with 0, and then next adder, basically, let me see, so it's 1024 by, what, 30 by 32 by 30 gives you 960, right? So 1024 by 960 minus, oh, hex mode again, 24 minus 960, 64. So I only need to do 64, which is 40 in hex. So compare compare X, and then branch if not equal to next adder, and we want to store that into 4017. So that's basically what we're doing. We're saying, okay, if we've gotten through the first screen here, well, check to see if we're totally done. If we're not totally done, then check for the attribute. If we're at the point where we need to load the attributes for the first screen, otherwise go to done loading tiles, which really should be to load the attributes for the second screen, but I'm not going to deal with that right now. So here we're checking the screen attributes to see if we hit the top of the first screen. If we didn't, then we're going to keep loading tiles. And then if we did, we're going to essentially write a bunch of 0 attribute information to the attribute bytes at the end of the first screen, using X as our counter, which means we should probably increment that. And once we have written the right number of bytes, we want to go back to load tiles. All right, so now when we load this and run it, we should see 2 different screens. One should be all of the gradient, and one should be all of the solid tiles. Not quite. So let's see. So we are, I guess, setting the attribute correctly. Maybe. We're not doing this right. Oh, okay. I know why. Man, this is a pain in the butt. Yeah, I know. I'm just adding another byte here. I want to just get this done for tonight and working. So store X into tile, what did I call it? Tile counter or something or other. Or no, tile screen counter. So the problem is that you can't do what I'm trying to do because Well, actually, no. That should work okay. Hold on a second. That should work okay because in level 1, it is actually, once you get past this, it should be the next Y value. So that's okay. So what did I mess up? So tile Y. So I'm checking tile X to see if we got to 32. If we did, then we're going to increment, we're going to zero out tile X, we're going to increment tile Y and M tile Y. We're going to check M tile Y to see if it was 4. If it is, we're going to make it 0. And then we're going to check tile Y to see if it's 3C, which is 60. And if it is, then we're going to, if it isn't, we're going to check to see if we need to load the screen attributes. Otherwise, we're done loading tiles. If it is not 3C, then we want to check to see, is it 30, which is 1E? And if it's not, then we want to go back to loading tiles. Otherwise, we need to use X as the counter, and then we're going to store the attributes into 4017. We're going to increment X until we get to we're going to increment X until we get to 60. Wait, no. Did I mess that up? Well, obviously I messed up something, but 64. No. Yeah. Oh, right. 64. Right. 64 bytes. I was like, why? But that 64 bytes is the attribute byte. So if it's not equal to 64, then we're gonna branch to the next attribute. We're just gonna keep doing that until we're done. And then we're going to jump back to load tiles, right? So once we do that, we're going to load tile X again, which should be 0 at this point. And then we're going to go through the whole thing again, except tile Y will now be, what would it be? It would be 31. So that should be fine because we're going into, oh, it's just me being dumb. This should be meta tile 1, not meta tile 3. And then, let me see. 1, 2, 3, 4, 5, 6, 7, 8. That should fix it. If you select meta tiles that don't exist, you're going to get weird data. Name table viewer. Okay. So that's the solid color, and then that's the, okay. So that actually looks correct. Sort of. Did I miscount this? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have this little bottom sliver here of meta tile, or of tiles that didn't get drawn for some reason. I'll have to figure out what that's about. And also, I noticed just now, that's weird. It's not totally drawing this right. What's all that about? So So tile 6A, or maybe it is, and it's just a weird artifact of the... Oh, yeah, you know, it could be a problem because of the palette that's being used. Which I'm not sure which palette it's actually using, so because they're all pretty similar, it could very well just be hey Eugene, it could all just be that it's looking a little bit odd because of the but that doesn't explain why, or maybe it does. Is it yeah, I'm not sure my brain is processing this at this time of night either. So let's see. So is it just these attributes are messed up for the palettes, or are the tiles messed up? Because the tiles look, the values look good, but when I, well, we can see this, right? So 69 is the starting point for the tiles, and I wish this was bigger because it makes it really difficult to view. So 69, 6A, 6B, 6C, and then 69, 6A. So that those tile values are right. I'm guessing that it must just have something to do with the with the palettes that are loaded. That's just strange that it's only half that way. And I'm wondering if it's just because I don't know how the palettes in the attribute table work properly. I was under the impression that by writing top left quadrant of this byte, top left, top right quadrant, top left, top right, I just want them all to be the zero, to be the same palette. Each byte controls the palette of the 32 by 32 pixel or 4 by 4 into 2-bit areas. Each area covers 16 by 16 pixels, which makes sense based on the way that this looks. You can see, it's, I guess, easier to see it in the emulator itself. You can see in the places where it's kind of messed up looking that it is 4 distinct color situations going on. But again, that's weird because I thought I was storing load adder. I thought I was just storing 0. Well, let's like really make sure we're really storing 0 in it. Interesting. If you look at the palettes, I mean, they're not crazily different palettes here, so that's not really helping me. What I can do is let's take a look at it's also possible that I'm doing something wrong and destroying the palette accidentally. So let's see which palette we can get rid of this palette here because that one's for the sprite character that I was messing around with. Oh, oops. So, well, that's fine. Let's just get the palettes rearranged here. So, this first palette, I'm actually okay with the blue, I guess. It was just different than what I was expecting. Alright, so now I see the orange color, which is this palette. Like, holy Christmas, where are these colors coming from? Is there a way to see? I like how it just randomly changes the mirroring on you. Can you... Oh. So you can see the address, but that doesn't really help me. What I want to see is... I want to see the attribute value. This is the wrong thing. I want PPU memory, and I want to start at PPU address 2000. And want is a strong word. I need to look at this. Okay, so that is fine. The data is good. So 2960 in hex is some value that the calculator is going to tell me. 3C0. So 23C0 is here. Okay. So I am overwriting. Interesting. So I'm overwriting the attribute values. Yeah. So, okay, so what I've done is I've loaded the meta tile information into the attribute values, which I shouldn't have done. And you can see as I change this in the PPU memory, it's changing the quadrants of my meta tile. So, interesting. So that, why is that happening? Man, it's like I feel like I ask myself that every 2 minutes as I'm working on this. It has something to do with my counters, I'm sure. The Y value should only be checking. Let's see. So let me just make sure I didn't mess this up. So it's 30 is 1E. So once it gets to the value of 30, let's do this. Let's set a breakpoint. We'll trigger a breakpoint here by writing to that 7FE value that I've been breaking on. And let's see what the values look like at that point, because I kind of thought that's what was happening, but it was weird because it should be counting properly. Let's see, debugger. Let's delete this breakpoint. And let's turn that on, and we hit enter, or start, I should say. All right, so we've gotten to, let's see, that 7FE. And then it should be doing a compare, which means that this is not the right spot here. Okay, so what is it comparing? It's going to store, okay, that's nonsense. It's comparing it against 1. I guess I want to see, I actually want to see this at the point that we think we should be storing the attributes. So let me reload this again. debugger, where are you now? Run. Run. Okay, hit start. And this is not the place, this is the place. So let's take a look at the PPU memory. We can see that it's been updated. 23C0 is okay, so that's good. We're actually okay, we're at a point where we want it to be. We want those values to be what we're updating next. So if we take this code and run through it, we're setting X and A to 0, and then we're storing it in 4017, and we're just going to keep doing that. So, like, I'm just setting garbage values here because I want to make sure that it's actually, oh no, wait a minute. What happened? Increment X. Y is... Oh no, this is okay. I thought it jumped out for some reason and didn't continue updating that memory. PPU memory. Step over. Am I writing to the wrong thing? Oh, I'm totally writing to the wrong thing. Damn it. 2007, not 4017. I don't know where that came from. Okay, that'll do it. So I was writing to that's a controller register, not a PPU register. All right, so reload. Debugger. Run. Press start. I don't think we need this on anymore. I think that's fine. Okay, that's better. That actually looks like what I expected it to look like. Yeah, that's okay. So that's interesting. That's actually okay. I mean, it's not exactly what I wanted it to do, but that is better than what I wanted it to do. So what it's doing is it is loading the entire map, including, it's doing the 32 by 32, and then it's getting to the metadata, or getting to the data for the meta tiles for the next screen, of which I guess there are too many meta tiles now. I'm reasonably okay with this, I think, for now. I mean, I might find out that this is actually totally going to be a problem, but I guess that what that means is, so if this is 32, we can only have 60 across, 60 down. Yeah, no, that's okay. It just means we have an extraneous row, I think, right? Because if we can, excuse me, 64, so this one row is actually not necessary because we're drawing the entire thing here into the next screen, and then we have the remaining. I think that's right. Yeah, that would work out if I'm still coherent enough to do some basic math. Okay. Yeah. Yeah, the only thing it didn't do is it didn't write the name table. Did it not write those attributes correctly again? No, that's good. And then it wrote the rest of the data for this. Okay, is it just actually finally working now? Yeah, I guess so. So in theory, what I could do now is I could, instead of writing all zeros, I could write ones and change the palettes, or well, it would be one. It's every 4 bits. So what is that? That's 1, 2, 4. That's 1, 2, 4, 8. Is that 5s? And that would select palette 1. Yeah, okay, cool. Alright, so that's cool. I actually sort of got that right. I don't know why that has 1 in... Oh, it's just... That's weird. Why is it doing that? It's something to do with the mouse selecting it, but... Alright, so that's got all 5s in it, which means that all of those quadrants are selecting palette 1. We could even do something crazy like... I don't know why we would want to do this, but load a 0, store a into temp, and then load a temp, it's lowercase, store it, and then increment temp, and well, that's not going to work exactly. Well, that's okay. We're just messing around. This is going to create some weird behaviors with the palettes that are used. Yeah, so you can see we got all sorts of crazy colors now, loading based on the palette selection, based on the bit pattern that we're loading in from the value of temp. So that's kind of cool. I guess I want horizontal mirroring instead of vertical. Right. I think that's the right bit. I'm just totally guessing from my distant memories of going through that initially. So that was wrong. Name table viewer. Oh no, it was right. It just didn't load the data right. Or I broke it. I don't know. Maybe that's the wrong thing. So let's go back to the header, and then I should really stop because I'm getting slap happy now. Where is the minus header? So this is going to be 1A, and then it's the size of the program, size of the char ROM, flag 6. No, I was right. That's vertical mirroring, which is a horizontal arrangement, so I changed that to 0. Why did that break things? Yeah, so that's right, and then what? It's like it changed. Oh, am I? Can you change that mid game? You can, right? Be very careful running the register outside vertical blanking if you're using vertical mirroring, horizontal arrangement, or it may cause the next scan line to be redrawn left. No, that's not why. How did that happen? That's bizarre. You can't change it. So, what on earth? Why did it lose which mirroring it was supposed to be using and break everything? And you can see it actually draws, and then is it because the memory address is different with this arrangement? No. Oh, maybe. No, it shouldn't be. It's just incrementing. That is bizarre. So by changing the mirroring, it broke my drawing. What's, you know, let's do this. Let's take a look at the. We have the attribute code. I'm doing modifications to temp. Maybe it's this. Maybe it's my nonsense with temp that's breaking this thing, and it just wasn't evident in. Whoa! Why is that was weird? Is it just FCEUX didn't like it for some reason? Because the menu disappeared. No? Okay. Let's do this. I'm going to reset the emulation speed to the slowest speed. And then I want to reload the ROM. Okay, and then I'm going to hit start, and then I should be able to see my tiles getting drawn. Wow. So although that was cool to see, did something, I wonder if the NMI occurred and broke this business. It's entirely possible that this is so slow it's getting a, let's do this. Let's wait. I'm gonna wait for v blank, and then I'm going to do it, and then I'm gonna wait for another v blank. Let's see if I wait for the v blank to occur, if that fixes this. And let's also increase the emulation speed just a little bit, because it's a little too slow. You're not picking up my start button. Press. Oh, it did. Okay. That's gotta be v blank occurring, or NMI occurring while I'm drawing on this. Let's do this. Because what it's gonna do is, anywhere I'm manipulating where we're updating the background, or let me rephrase that. anywhere where the NMI is modifying where you update the screen is going to cause that address to get changed, and then it's going to change how we're writing to the video memory. So I'm wondering if what we need to do is do something like this, because right now let's see. Yeah, so it's doing exactly that. It's changing the palette. Okay. All right, this is bizarre. So so this is checking if it's title screen, and if it's not equal, then it's going to process gameplay state. Otherwise, what is this doing? Oh, it's changing the palette. So compare to what is this? Load new game state. Branch of equal to done with PPU. At this point, we don't want to do, if we're in the middle of loading a new game state, we should not be doing any of that stuff yet. Where am I? Loading to load new game. Forgot what my constant was. Yeah, of course that's a range error. Branch not equal to check next state. Check next state is here. Otherwise, we're going to jump to done with PPU. Range errors are my favorite. Okay. So let's take a look at this again. So we're going to hit enter or start. I keep saying enter. And now we should be good. No. What? Compare game state, load new game, branch if not equal to check next state. Otherwise jump to done with PPU. Is done with PPU also? No. Is it that we're changing the game state early? Compare, load new game state. We're storing the game state here. Do we change the game state yet? No. We're not changing the game state here. Where are we changing the game state? We're changing it after we're done loading the tiles. So something else is it just simply the NMI itself that is causing this? I guess it's possible. Let's take a look and see if there's any warnings about this. Let's see. Neither has direct access to the other's memory. The CPU, yeah. PPU status to reset after reading the oh, yeah, I'm not doing that. So let's do that. 2006. So let's load a 2006 to clear it out. And then that's for loading the title screen also. Wait a minute. After reading PPU status, oh, that's this guy. So I should be doing this here. I don't think that's going to fix it, but can I increase the speed a little bit? It's a little painful to be sitting there while it loads all of that. Damn it. Access to PPU scroll and PPU address during the screen refresh produces interesting raster effects. Where am I modifying this? Check next state. Compare it to title screen, branch if not equal gameplay status. But we're at load new game. The only thing I can think of is that the status hasn't changed. Well, no, it should be at load new game at this point. Load a game state. Compare game state to load new game. Branch if not equal to check next state. Otherwise done with PPU. Compare game state to title screen. Branch if not equal to process game play state. Otherwise it is setting up for palette changes. Right, because when we're in the game, yeah, so when we're in the process of it being in the title screen, we're swapping the palette colors so we can do the blinking. Press start. This is all of the code for, well, it's not all of the code, but it's the code for drawing our sprites, which gets generated by the asset tool. Done with PPU. Bizarre. I mean, I assume that this is okay, but it doesn't even matter what we store in the address. Where is the debugger? Holy Christmas, this is... Yeah, okay. That was a bad place to put it. What I want to do is I want to see if it actually calls this in this location when we're loading the new game. Okay, we're not. Okay, so hit start. Okay. This is our code for what? Load X. What is that? Okay, this is, yeah, so this is the code that's loading the tiles. And then store A, 7FE, jump. It's not a jump, this is a load A. Do we have too many places where we're doing this now? Yeah, we do. I just want it in this one place. So all right, that's the initialization of the memory. We have our start screen. We press start. This is an NMI that occurred while we're in that process. What? Oh, we're already in the process of running the game now. Where is it doing that? Store A7. Oh, did I put that into here? No, that's bizarre. What's actually calling that still? That's the only place that it should be doing that is, and yet it's compare 1 branch if equal, compare 2 branch if equal. This is sprite drawing logic. Oh yeah, here it is. Annoying. Alright, let's try this again. It's a problem when you have it set to case sensitive search. Oh man, okay. So let's go past the clearing of the data. We're at the start screen and press start. We are at 1 NMI where it is loading the data. And okay. So it never hits another NMI while we're loading the background, and yet it's still wrong. Why? Why is that getting reset? Am I doing something strange? Like I'm writing these attribute tiles or attribute bytes. Oh, I don't need to do that anymore. Run. Just in case that was it. No. I am not entirely positive. I wonder if this is also potentially related to, I know we had a conversation on Discord about the fact that we should not be doing what I'm doing with the NMI and turning it off. So maybe I'm gonna not do that. Maybe I'm gonna stop messing with that. What was I think you can turn rendering off, which is something that I want to do because I don't want it to show the background as I'm drawing it. But I don't want to mess with that. Let's leave that alone. Store a swap. This is that, and then I'm not going to actually store that into 2000. Let's see if that fixes the problem. If maybe I'm messing something up by artificially turning the NMI, or not artificially, but unnecessarily messing with the NMI, which seems to be frowned upon. Okay, so now multiple NMIs are occurring. So what I'm seeing, still the same behavior. Oh, I wonder if the memory mapping I wonder if it's just a simple case of the memory mapping is different for horizontal and vertical, because I mean that would make sense to some extent. I would have thought that it would have been linear, but if this is 2000, this is 2800, this is 2000, that is not 2800, that is 2420. So do I need to, I guess I need to change the address that I'm writing to after the first screen is written. That's weird. I guess I should have checked that first, but I would not have thought that the mirroring changed the address since it's mirroring, but obviously it does. So, I mean, it's a simple fix if that's all it is, because what's happening is I'm essentially just rewriting the memory, which is what we're seeing. So after we're done with the attributes, I need to load the new address, which is, what was it, 2400? 2400. So 2400, and then reload, and let's change, well, I'll just speed up emulation a little bit, just because it should be okay now, I think. Or closer, at least. No? Oh, did I not build that? It's possible I didn't build that. No. Branch not equal to that. 2400. Right, what's the deal? $28, 20, 2000. So it should be 2400. What's this? This is 2800. Okay, so that fixed it. So I just wasn't writing to the right location in memory, but that is bizarre. I'm not sure. I'll have to read up on that. I don't know. I don't know enough to know why I didn't know that. I guess in my mind, because the mirroring is essentially mirroring across this way, I thought that this location that's being mirrored really had no relevance to what was being done on the non-mirrored side, but obviously it does. And what we were seeing is that once we got to the end of this screen, and we got to 27, where would that be? Or 28? Well, 2800. Oh, okay, no, it would be right before 2800. But once we got to the point where we were at the bottommost part of the screen, I had assumed that the next memory location would automatically be 2800. And for some reason it wasn't. I guess, okay, and the reason it wasn't is because it was actually going to this 2400 location. And I'm talking about the location shown here in the PPU address. It was going to the 2400 location because I guess, let's see, yeah, so you get to 23 and change, and then you have your attribute values, and then you get to 2400, which is essentially this mirrored. So if you write to this with this stuff, it's going to overwrite it, I guess. So what you need to do is say, okay, because I know I'm doing horizontal mirroring, I need to jump to 2800, address 2800 in the PPU memory, and then write out the rest of my tiles. That's okay. Well, you know, that's fine. That was interesting. So I learned something. All right, so we're at almost 3 hours streaming here, so I'm gonna wrap this up. Anybody on the stream have any questions? No, I don't see any questions, but like I've said on every other stream, if you'd like to ask me a question, I am on Twitter at Clairvus. I am also on the Nintendo Age Discord and also the forums, although I realized I never said that I am on there as Xelius, Xelius, instead of Clairvus, because I had signed up that way when I first joined. But feel free to also comment on the recording that I'll be posting on YouTube once we're done here. And like I said at the beginning of the stream, I am going to be off from streaming this next week, so there won't be any stream Monday or Thursday, but we'll resume the following week with more streaming Monday and Thursday. Hopefully I'll be a little refreshed, and we'll be good to go. And yeah, have a great night. Thanks for watching.